So we are going to talk about how to multiply monomials together. So this is a video on how to multiply monomials together. Now, monomial. Can anyone tell me what mono means? Margot?
A disease.
Mononucleosis is an illness. That's not what I'm asking. What I'm asking is, what does the prefix mono mean? Yes? It means one. So mono means one. Nomial means term. So we're talking about things that have one term. And you'll remember that terms are going to be separated by addition or subtraction signs, not multiplication and division. Now, in our previous week's algebra sheet, we were adding and subtracting polynomials, and we were only allowed to combine things that had identical variables. That means the letters had to be the same and the variables and the exponents had to be the same. You may multiply or divide any term regardless of what the variables are. Okay? So adding and subtracting, the terms must be identical. So the variables must be identical. And in multiplying and dividing, you can multiply and divide anything you wish. Okay. So I'm going to first start with the rule. And I'm going to write the rule down. It's really not too hard, but here's the rule. The rule is a to the x power times a to the y power is equal to a to the x plus y power. Now, I realize that when it's written in its basic rule form, it's somewhat scary, but it's really not too bad, and we'll show some examples of why it's not too bad. A little delayed reaction here. All right. So here's our rule. And so let's start with numbers first. Now, I'm not going to ask you to multiply this out because it would be a waste of your time. Let's say we had 10 to the 10th power, and let's multiply it by 10 to the 20th power. So we're talking about a number that is astronomically huge. So what does the rule say? Well, the rule says that if I have two bases that are the same, what am I going to do with the exponents? I'm going to add them. Now, in this case, the base is 10 because we have 10 to the 10th and then 10 to the 20th. So this is going to be equal to 10 to the 10 plus 20 power. By the way, this is how you would show your work on your sheet. But 10 plus 20, well, I can do that, right?
Yeah.
So this is equal to 10 to the 30th power. And so here's the answer. So the rule is not really hard to apply. Excuse me. Excuse me. So moving on. So first we tried it with a number. Now we're going to use this rule with letters. So we're going to start with Alec because he's not paying attention. We're just going to say Alec to the 4th times Alec to the 3rd. Well, are my bases the same?
Yeah.
Yes, A and A. So what am I going to do with the exponents?
Add them.
So this is going to be equal to a to the 4 plus 3 power, which is equal to a to the 7th. So this time I'm going to come up with another problem. I want you to do the problem and stand up when you know what the answer is. This time we're going to have Robbie to the 5th times Robbie to the 7th. Stand up when you know the answer. All right. So how many Robbies do we have? Robbie. Now we have Robbie. Robbie to the 12th. Please have a seat. Yes, Ashby. The same rule would apply. But you can't add, you're right, you can't add two letters that are different. So it would be like x plus y or 7 plus z or whatever. You would have to leave it with the variable in the exponent. Okay, so now let's try a slightly different problem. Well, as you are aware, most people do not just go by one name unless you're Madonna or
Raven Simone. She went by Raven.
Raven Simone.
I think I just didn't know her last name, but I think
I have no idea who that is.
that's a Raven.
All right, so we'll move on.
And Rihanna.
Kate is like, oh my God, these people are so embarrassing. All right, so now we're gonna have Michael squared Winokur to the fourth, and we're going to multiply that by Michael Winokur to the third. Now we have two variables. We have m's and we have w's, and we're multiplying it together. Now we know that multiplication can be written in any order, and it's not going to change the answer. Because what is 4 times 5?
20.
What is 5 times 4?
20.
So that did not change the problem when we switched the order. So we're going to take m squared. Well, what's another way of writing m squared?
M times N.
M times m. So we have m times m. So here's our m squared. And we want to multiply it by the other m, the other Michael. Well, what power is this m taken to?
3.
No, this is not to the third power. No, because this is to the first power.
Oh, 3.
Because 3 to the first power is just 3, right?
Mm-hmm.
So anything to the first power is just that number, right? So we have m to the first, so we're going to put it here. And we're going to multiply this. Well, what's another way of saying w to the fourth?
W times W times W times W.
1, 2, 3, 4. All right. So this here is w to the fourth. What's another way of saying w to the third?
W, W, W. Oh, I would multiplication.
W times w. And so here's w to the third. So how many m's do I have in total?
Trace.
I have m to the third power. Incidentally, what is 2 plus 1?
3.
Oh, so we're just adding the exponents, aren't we? How many w's do I have?
7.
So I have w to the seventh. Incidentally, what is 3 plus 4?
7.
7. Now, this is why this is why this rule works. Because if I were to expand the variable out, put all of the same variables together, I would be able to count how many they are, and then that's the exponent, right? So this rule makes complete logical sense, which is great. So let's try one more. This one's going to have two variables again, and incidentally, I can have as many letters as I want in these type of problems, and they'll work out just fine. So, oops, that's the camera. I don't want the camera. So let's try this one. Let's try Nick. What's your soccer number, buddy? 14. We have Nick to the 14th. Miller, what's your personal favorite number? 24. And we're going to multiply this by Nick. How old is your brother? 15. And how old's your mother?
I have to know that. That's terrible. Wow, that's not
29. No, just. Anyways, so go ahead and multiply that out. Multiply that out. She doesn't look over a day past 29. Kara, my apologies.
She's drowning.
I know, she's downstairs thinking, oh my God, goodness, I can't believe he said that. All right, so what is the answer? Stand up when you have the answer.
Like, do you have to, like, put all of it out?
No,
Oh.
we're just adding the exponents. No, you can stand up, Michael. All right, Josie, what was your final answer? Hold on a second. I can't hear you. Kate, I appreciate your cooperation. Josie's in the back of the room. I can't hear if you're talking. Yes. End of the 29th. M to the 53rd. Okay, you may have a seat. Are there any questions on how this rule is applied? Okay. So we have learned how to multiply monomials, Aiden, together. Are there any questions that you'd like me to address before we move on? Is it a real question, Livy?
Yes.
Yes, Livy.
Okay, so do you put the multiplication sign between them?
No, you don't have to. Because you know, for instance, if I have 3 times x, when the two terms are put together, it means multiply, right? Right. So if I have nm, that means n times n. So the 29 is only applying, the exponent of 29 is only being applied to the n. The exponent of 53 is only being applied to the m. Yes, Sam?
Wouldn't it be just easier to combine the two bases and just to get n m, whatever the exponent is, times n m?
Okay, I'll show you why that does not work. Okay, so the question is, wouldn't it just be easier to write n, m, and then add these exponents? So that's going to be what, 70, 80.
You can't do that because they are not similar terms.
We will. They are not. The bases aren't the same. But I'll prove that to you. So here we go. Let's erase this. So let's try this. Let's try this. So using your calculator, and Ashby, you're going to be asked to lead us on some of these here, so be ready. So we have, let's say we have 2 to the 4th times 3 to the 6th. And the question was, does that equal 6, because that's 2 times 3, right?
Yeah.
To the 10th. So go ahead. Boys, I would like you to figure out the answer to the left side. Girls, the right side. All right. 2 to the 4th times 3 to the 6th, what do we get? Aiden? Say it again.
Maybe 6 to 24 pounds.
No, that's not. I want you to actually do, Aiden, I want you to actually do 2 to the 4th, then multiply it times 3 to the 6th. All right, so 2 to the 4th times 3 to the 6th, what is the answer, Harper? 11,664. What is 6 to the 10th, Kira?
60,466,176. That's what I got.
It's 400.
All right.
All right.
They don't equal the same thing is the
No
point.
way.
So if the bases are the same, you may add the exponents. If the bases are different, you cannot.